Assalamualaikum warahmatullahi wabarakatuh. This is our project presentation from Group 3. This is our group members, consists of 6 group members. Our project name is Rock Slope Stabilization Method. Okay, let's move on to the next slide. This is table of content that consists of 5 components in our presentation.
Assalamualaikum and a very good day. My name is Nur Shaira Bidi Maidin.
Introduction. Soil stabilization involves binding soil particles together, waterproofing the particles, or a combination of the two to improve soil strength and resistance to water softening. Two broad categories of soil stabilization methods. The first one, mechanical stabilization. By modifying the physical nature of native soil particles by induced vibration or compaction, or by integrating other physical qualities like barriers and nails. The next one, chemical stabilization. To reach the optimum effect, soil stabilization is mostly dependent on chemical reaction between the stabilizer, which is cementitious material, and the soil materials, which is pozzolanic materials. Unbound materials can be stabilized with cementitious materials through soil stabilization. The stabilized soil ingredients are stronger, less permeability, and less compressible than natural soil. Volume, stability, strength, compressibility, permeability, and durability are the most important qualities of soil for engineers.
Hi, Assalamualaikum. My name is Muhammad Aidi bin Ismail. So the next part is literature review. At each slope, there is a force that tends to promote downhill motion and a counter force that tends to prevent motions. The general definition of the slope safety factors comes from comparing the downslope shear stress along the known or assumed fracture surface with the ground shear strength. Other than that, some external or internal reasons that may reduce shear strength or increase shear stress. There are reasons that simultaneously affect the two terms of the safety factor ratio. The various slope movements reflect the diversity of conditions that make the slope unstable and the process that triggers the movement. Therefore, soil conditions such as weak resistance, sensitive tissue, degree of weathering, and fracture are the influencing criteria but not the cause. There are also some factors that causing slope failures, which is erosions, rainfall, and external loading. For the erosions, water and wind continue to erode natural and man-made slopes. Erosion changed the geometry of the slopes, which eventually led to the collapse of the slope, or more accurately, a landslide. For the rainfall, long-term rainfall will saturate, soften, and erode the soil. When water enters existing cracks, will weaken the underlying soil layer and cause failure. And lastly, for the external loading, the loading placed at the top of the slope will increase gravity loading and may cause slope damage.
Hi, Assalamualaikum. My name is Zulaika binti Jamil. For this method, it is very important to understand the slope configuration and scale as well as the dynamic state in order to investigate the actual state of the slope and designing countermeasures. It is also very necessary to clarify the relationship between each characteristics from the analysis of the characteristic of the existing slope. Not just that, the relation between the scale of the slope and the profile or the slope angle is based on examples taken from the side. So this method consists of composition properties of slope that can be determined by 4 components, which is slope width, which is slope maximum width, and slope depth, which is the vertical slide surface maximum depth, and slope length, which is the ground slide distance between the head and foot, and last but not least, the slope angle, which is the inclined angle horizontal line between the head and toes of the slope. So now I will pass the presentation to my fellow teammates to proceed the presentation. Thank you.
Hi, Assalamualaikum. My name is Muhammad Arif Afifi bin Jupri. For the next part is result and discussion. Artificial slope within metropolitan areas that are part of developments or next in infrastructure like highways and railroads, on the other hand, can be less stable and could necessitate stabilization. The choice of an effective slope stabilization method necessitates a detailed examination of the existing slope condition as well as an assessment of the main reason of slope instability. Following the identification of the reason of slope stability, the most appropriate slope remedial measure is chosen based on feasibility, stability, and cost. There are two slope stabilization methods that have been identified. First is geometrical method. This is the most popular strategy where this procedure is usually straightforward and inexpensive. The stabilization of the slope can be improved by altering the slope angle from step to mill, and the angle is usually supported by grass bonding with the soil. This traditional method of angle grading necessitates considerable digging. This approach does not require a lot of load resistance and uses of creeping grass surface to naturally maintain the slope. The second method is drainage method. The saturation and pore water pressure built up in the subsoil is one of the slope failure reasons. If a drainage system has been installed, the risk of pore water pressure and subsoil saturation increasing would be reduced. This strategy has the potential to be incredibly effective. However, the drainage system must be maintained in order to function properly. The surface drains are easy to manage while the subsurface drains are more challenging. Surface drains were generally employed with geometrical methods, whereas subsoil drains were part of a strategy that included a retaining structure. To avoid the consequence of significant volume of water absorption by the slope, a surface drain is capable of discharging more water, especially during heavy rain.
Assalamualaikum, my name Muhammad Azri bin Nizamdin. This procedure is usually more expensive. However, because of this technique retaining structure method, its versatility is in a confined environment. It's always the preferred method. The idea behind this strategy is to create a retaining structure to counteract the soil mass down forward forces. As we can see, this retaining structure include gravity retaining walls, cantilever walls, contiguous bulk pile, caisson, and steel sheet pile. If the driving forces are too great to resist, ground anchors or other tie-back system may be utilized in conjunction with the retaining structure. Okay, for the discussion, in slope stability analysis, risks and uncertainties related to properties of the soil has to be investigated. Due to composite nature of soil, the special variation in its properties are obvious in actually the product of natural geological process. It is necessary to adhere to a proper risk assessment plan for managing the risk with landslide.
Assalamualaikum and hi, my name is Adilizati binti Adilzani.
For the conclusion, when the shear force in the soil functions as the force retainer against gravity, it will cause significant geostatic stress when the ground surface is at specific angle. Thus, the slope is considered as stable. The vertical and horizontal stress, defined as lateral stress, make up geostatic stress. Okay, for soil loading of structure that are directly on sloping soil or loading that occur in a neighboring region is considered as an imposed load. Okay, for soil has the ability to operate and lessen the bonding force between itself. A landslide will happen if the stress exceeds the soil shear force. Aside from that, development in the upstream area will boost the amount of water flowing downstream, contributing to land collapse. With the installation of drainage system or a retention pond, okay, the running water may be safely flowed. Okay, for slope surface configuration established by data gathering have given rise to the concept of retaining structure design as a result of the methodologies utilized in this study. These preliminary procedures are critical in determining the source of slope instability and collapse. Apart from the soil stress component, whether vertical or horizontal, the hot and humid environment in Malaysia adds to soil collapse. That's all from us. Thank you.